Good morning, students. Welcome back in your physics lecture. So, students, before starting today's lecture, here is one question for all of you. Try to answer this question. So, the question is, name the forces that oppose the motion of a body projected in the vertically upward direction. Think about the correct answer. Well, if you come to the right one, then you are correct about it. The answer is gravitational pull of Earth and resistance due to air. So therefore, whenever a body is projected in the vertically upward direction with a certain speed, then the body comes under the action of both these forces, and these forces oppose the motion of the body. So we can say that gravitational pull of Earth and resistance due to the air opposes the motion of the body. So body rises up to certain height, then fall back to the earth due to these forces. The two opposing forces, that is the gravitational pull of earth and resistance due to air, decreases with increase in distance from the center of earth. Therefore, if the body is projected with greater speed, it will attain a greater height before falling back to the earth. And if we go on increasing the initial speed of the projection of the body, it will attain larger and larger height. Finally, a stage reaches when the body rises so high that it crosses the gravitational field of the earth. Once the body goes beyond the gravitational field of earth, it is no longer attracted by the earth. So hence it will not be able to return to the earth by itself. So the minimum speed of projection required to achieve this stage so that body will not be able to return to the earth by itself is called the escape speed. In other words, we can say that the minimum speed with which a body should projected in the vertically upward direction from the surface of Earth or any other planet so that it can overcome the gravitational pull of the Earth or of that planet and never returns to the surface of the Earth on its own is known as escape speed. So now we are going to understand the expression for escape speed. For this, let us consider a to be a perfect sphere of mass capital M and radius r with center at O. Suppose a body of mass small m is lying at a point capital A at a distance small x from the center of the earth. So according to Newton's law of gravitation, the force of attraction between the earth and the body having mass m is F is equal to capital G mm divided by x square. Here capital G is universal gravitational constant and this force acts towards the center of the earth. And from the image it is clearly understood that earth is to be perfectly sphere having the radius r and the mass capital M, and here is a body of mass small m lying at a point capital A and its distance from the center of the sphere is small x. So from this figure everything is clear. So now we are going to solve for the expression of escape velocity or escape speed. Suppose that a body is moved from point A to the point B through a small distance dx. So we can say that AB is equal to dx. So from the previous equation of the force of attraction from the Newton's law of gravitation, so that force has to be applied on the body in the upward direction. So in moving a body from a point A to point B, we have to do some work, and let us suppose that is a small amount of the work, that is a dw. Why we take a small amount of work? Because there is a small distance covered by a body. So this work done dw is called small amount of work done, and this work done has to be done against the gravitational force, so that the body just escape from the attractive force of the earth. So this work is done against the gravitational force by the earth on the body to raise it from the point A to point B. We know the expression for work done is equal to force into displacement, and here the value of the force we get from the Newton's law of gravitation, that is gmm divided by x square, and this equation get multiplied with dx, so the resultant equation is gmm multiplied with dx divided by x square. If capital W is the total work done, which is done against the gravitational force exerted by Earth on the body in rising it from the surface of Earth to infinity. Now look at this figure. Suppose we are taking the object or body from a point A or to infinity, then in that case we are doing work against the gravitational force. So for this, the total work done to take the body up to infinity is W. So to calculate the total work done, we take the integral of the small work done with lower limit from capital R to the upper limit infinity. Put the value of the dw, then after that solve the integral. After solving the integral, we get the value minus of gmm into 1 upon infinity minus 1 upon r. So where the final answer is work done is equal to gmm divided by capital R. Now for a body to escape from the surface of the earth, the kinetic energy of the body must be equal to the work done against the gravity. When the work done is equal to the kinetic energy of the body, then the body is able to escape from the surface of the earth. Now from this we can write this term mathematically, like half mve square is equal to gmm divided by r. Here ve represent the escape speed with which the body is moving against the gravitational attraction or gravitational pull of the earth. Now from the equation half mve square is equal to gmm over r, we can get the expression for the ve. So ve is equal to under root of 2 gm divided by r. As we all are aware about small g, that is acceleration due to gravity, and the value of small g on the surface of earth is gm divided by r square. Here in the expression of the escape velocity, here is gm. So in place of the gm, we can put the value from acceleration due to gravity, and we get gm is equal to small g into r square. On cancel out the terms of capital R, we get the final expression for VE, that is equal to under root of 2gr. So now we can calculate the escape velocity or escape speed from the surface of the earth. As we know, the equation for the escape velocity is V is equal to under root of 2gr. We know the value of the small g, that is acceleration due to gravity, is 9.8 meter per second square. We are aware about the radius of Earth. So put both these values in the expression for the escape speed. Then on calculation, we can find the final answer, that is equal to 11.2 kilometer per second. So dear students, calculate the expression and then finally compare your answer. So this is the escape velocity of Earth, that is 11.2 kilometer per second. Now it is a time for numericals. Calculate the escape velocity on the surface of moon. Given that radius of moon is 1.7 into 10 raised to power 6 meter and mass of moon is 10 raised to power 22 kg. So as per the given terms, we have the value of r, that is a radius, and the value of m, that is the mass of the moon. We know the expression for the escape velocity under root of 2gm over r, where capital G is the universal gravitational constant and its value is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. So we can put all the values of all the terms data in the expression of escape speed. After doing calculations, we get the final answer, that is 2.4 into 10 raised to power 3 meter per second. So dear students, you can do the calculations by yourself and then check your final answer. Now second numerical, find the velocity of escape at the moon. Given that its radius is 1.7 into 10 raised to power 6 meter and the value of its g, that is acceleration due to gravity at its surface, is 1.63 meter per second square. So first of all, write down the given terms. Then we are aware about the expression of the escape velocity, that is under root of 2gr. Put the value of small g and the capital R, then do calculations. So dear students, after doing calculations, check your answer. It will be 2.354 into 10 raised to power 3 meter per second. Then change the units or do the conversion of the units into kilometer per second. So we can say that in kilometer per second, our answer is 2.354 kilometer per second. So now here are few questions related to the topic, and these questions are depend upon our knowledge on the concepts so that we can get the answer and relate our concept to our daily life. Question number 1 is, what velocity will you give to a donkey and what velocity to a monkey so that both escape the gravitational field of Earth? So there are two animals, one is donkey and another is monkey. So it is very clear both have the different masses, but for the escape velocity, we know that escape velocity is independent of the mass of the body. It only depends upon the mass and the radius of the planet, but it shows independent nature regarding mass of the body. So we can say that we will give them the same velocity as escape velocity, as they are independent of the mass of the body. Question number 2 is, does the escape velocity depend upon the direction of propagation of body? No, it does not depend upon the direction of propagation of body, as there is no relation of escape velocity with the location from where it is projected. Question number 3 is, does a rocket really need the escape speed of 11.2 km per second initially to escape from the Earth? No, a rocket can have any value of initial speed, but its speed should goes on increasing and it will escape from the Earth only if its speeds become 11.2 km per second. So dear students, thank you for watching this. Try the numericals. Take care. Have a good day.